Hi there, folks. Today we're going to start talking about rules of exponents, starting with zero and negative exponents. All right, so we're going to kind of use a pattern here to determine what the rule is for zero and negative exponents, just to give you a feel for this thing. So if I were to consider kind of this XY chart thing going on here, if I were to look at these values, and I'm just going to start with the ones I know, I'm going to do the 2 to the 4th all the way down to the 2 to the 1st, and then we're just going to kind of look at the pattern that's created to figure out the rest of these. So 2 to the 4th power, remember an exponent of 4 means multiply 2 by itself 4 times. So 2 times 2 times 2 times 2, and when you multiply that out, you can use a calculator if you need to, but it's 16. 2 to the 3rd power is 2 times 2 times 2. It's 2 being multiplied 3 times, so that's an 8. 2 to the 2nd power is 2 times 2, which is a 4. 2 to the 1st power is just 2 times, well, there are no other 2s, so it's just a 2. Okay? So that's how exponents work, and we already have a sense for how those work. But now let's look at the pattern. So ignore the exponent that's being used and that kind of stuff. We don't know what 2 to the 0 power is yet, or 2 to the negative 1st, or 2 to the negative 4th. But look at the pattern of the numbers over here. I started with a 16, and then it became an 8, and then it became a 4, and then it became a 2. If I only look at those numbers, if I look at that 16, 8, 4, 2, what is the pattern? And hopefully you're looking at it going, well, the pattern is you're dividing by 2. 16 divided by 2 is an 8. 8 divided by 2 is a 4. 4 divided by 2 is a 2. And if I continued that pattern, 2 divided by 2 is a 1. If I continued that power, 1 divided by 2 is a 1/2. If I continued that pattern, 1/2 divided by 2 is a 1/4. Okay? And so as we look at this, this gives us an idea of what zero and negative exponents do. And since we continued the pattern, this is actually accurate. 2 to the 0 power is 1. 2 to the negative 1st power is 1/2. 2 to the negative 2nd power is 1/4. Spoiler alert, 2 to the negative 3rd power is 1/8. Okay? And so hopefully this starts to give us an idea of what zero and negative exponents do. You'll see here the 2 to the 0 power is 1, and what you would find out is if we did this pattern with other numbers, that 3 to the 0 power would also be 1. 4 to the 0 power would also be 1 as we conducted this same kind of pattern setup. All right? And what we would find out is that anything to the 0 power is essentially 1. All right? When we look at the negatives, we know that 2 to the 1st power is 2, but 2 to the negative 1st is 1 over 2. Okay, and hopefully you can kind of see that. 2 to the negative 2nd power here. Ready? 2 to the 2nd power is 4, but 2 to the negative 2nd power is 1/4. Okay, and so what you should start to realize is that negative exponents are just another fancy way of writing division. You know, you'll probably recall that I said fractions. Fractions are just division symbols. A fraction bar just means divided by. Well, a negative exponent just means divided by that thing. Okay, so 2 to the negative 2nd power just means, hey, divide by 2 to the 2nd power. That's where we get the 1/4. Okay, if I had 2 to the negative 3rd power, it's saying, hey, divide by 2 to the 3rd, which is 1 divided by 8. Okay, and so we'll kind of see that as we move forward. So here's the rule. First of all, anything to the any non-zero number to the 0 power is 1. Okay, and so here's the thing: the whole non-zero thing. Some of these rules don't work. I can't do 0 to the 0 power, right? I can't do 0 to a negative exponent. All right, so just remember it doesn't work with 0, but that's not that important for our purposes. Okay, so anything to the 0 power is 1. For example, right here, 27 to the 0 power. You guessed it, it's a 1. Amazing. Okay. Oh, a little bit of a bigger number here. 829,073 to the 0 power. Yeah, you got it. It's a 1. All right. Anything to the 0 power is 1. But now this one's a little bit tricky. You know, when you look at things, you probably noticed on your calculator, something like this. If I had -2 in parentheses to the 2nd power, the calculator would tell you it's a -4. Or sorry, a +4. But if I had -2 without the parentheses to the 2nd power, the calculator would tell you it's a -4. And the calculator's not wrong. This is an order of operations thing. See, the parentheses force me to apply the negative first, all right? But without the parentheses, I do 2 to the 2nd power. I do the exponent first and get a 4. Then I apply the negative and get a -4. It's order of operations. And so it's the same thing here. If you're looking at this thinking 1, you're close. It's actually -1. See, I do 17 to the 0 power is 1, then tack on the negative. And keep in mind, if I had negative 17 in parentheses to the 0 power, then it's a positive one, because then I'm doing the whole thing raised to that power. All right, so just be aware of that kind of stuff. All right, those subtle differences in terms of parentheses versus no parentheses make a big difference when talking about negative values being raised to a power. Okay, but anything to the 0 power is 1. So now let's talk about negative exponents. Ready? Negative exponents, we've kind of already seen it. It just means, hey, that negative symbol up there just means divide by that thing, all right? And so what I do is I flip it to the other side of the fraction bar, and I make the thing positive, all right? And I do that because essentially the negative is saying divide by that thing raised to that power, all right? For example, if I look at something like this guy, right now I have 7 to the negative third power. Really, that negative just means, hey, divide by this thing instead. So this is saying, hey, do 1 divided by 7 to the third power, all right? Divide by 7 to the third power, and 7 to the third power is 343. That's it. Okay? Negative exponents do not make things negative. That's the most common mistake that students make. We want to make something negative. No, a negative exponent means divide. So here I have x to the negative second power. That means I want to divide by x to the second power. So it's 1 over x squared. Okay? Same thing here. And see that negative. Remember, the negative kind of goes on separately, so I'll tack the negative on. But now let's look at 2 to the negative fifth power. That negative means, hey, divide by that thing. So I want to divide by 2 to the fifth power. And now I can simplify. So that's a negative 1 over 32. And notice the negative just kind of sticks around, all right? So again, only if you have parentheses does that negative take part in the exponent. If not, you just keep the negative on the outside, okay? If I look at something like this guy, 9 to the negative second power. The negative exponent means divide by that thing. So instead of 9 to the second power, I want to divide by 9 to the second power. That's what the negative exponent does. And so that's 1 over 81. But again, we're just flipping it to the other side of the fraction bar. If I look at this guy, right now I have 3 times this guy. Well, let's see. Let me leave the 3 out here. 2 to the negative third power, that's the same thing as doing dividing by 2 to the third power. So we flip it. Okay? That's what a negative exponent does. And now let's simplify. 3 times 1/8, and that's a 3 over 8. Just leave it as a fraction, okay? Remember, that's over 1. We multiply the numerators, multiply the denominators. Oh, here we go. See the parentheses around that negative 3.6? So that whole thing raised to the 0 power, anything to the 0 power is 1, okay? And the reason it's a 1 this time instead of a negative 1 is because we have that negative in parentheses. If that negative wasn't in parentheses, then it would be a negative 1 because we do the 1 and the negative would just tag along on the outside. Okay? So here's a couple more with some of these more complicated pieces in terms of having a couple more things floating around. The thing that students struggle with is which thing does the negative apply to? So like when I look at this one, that 5 has an exponent of 1. Anytime you don't see an exponent written, the exponent is 1. So it's 5 to the first, then a to the third, then b to the negative second. Okay, so that exponent of 3 only applies to the a. That exponent of negative 2 only applies to the b. So the 5 and the a to the third stay exactly the way they are. They don't change. But now b to the negative second means I want to divide by that thing instead. Okay? And here's where it becomes tricky. So something like this guy, again, that negative 2 only applies to the a value. See, that's 4 to the first power, all right? And so the 4 stays exactly where it is. That's a 4. The b is b to the second. But now here, the a to the negative second, I want to flip that. I'm going to send it down here because I want to divide by that thing instead. The thing that's confusing is down here I've got c to the negative fifth. That's actually going to go to the other side of the fraction bar. And so as we start to get into this, usually the way we remember this rule is we want to flip the thing to the other side of the fraction bar and make it positive, all right? But the reason for that is because I'm dividing by division. And if you recall from dividing by fractions, dividing by a fraction is the same as multiplying by the reciprocal. So dividing by division becomes multiplication. That's why that c goes to the numerator. But again, because it's division, essentially we're just flipping it to the other side of the fraction bar and making it positive. Same thing here if I look at this guy. Right now that's going to be a 1 over m to the third, n to the fifth. I flip it to the other side of the fraction bar and I make it positive. The negative exponent becomes division. If I look at this guy, once again, the 2 and the x to the third stay where they are. But the y to the second, I'm going to put down here. I flip it to the other side of the fraction bar and make it positive. And then the z to the negative fourth, I flip it to the other side of the fraction bar and I make it positive. Okay? When I change that thing to division, it flips to the other side. Okay? If I look at something like these guys, if you're evaluating, if you're plugging values in, my recommendation is to simplify the negative exponents first before we plug in those values. Okay, so before I plug the 2 in for A and the negative 3 in for B and the negative 1 in for C, I want to take care of those negative exponents. I want to simplify it as far as I can first and then plug in. So this one, once again, the 3 does not apply to that negative 3 right here. That's 3 to the first. The a is the only thing with the negative exponent. So the 3 and the b squared stay where they are. The a to the third goes in the denominator and I make it positive. The negative exponent causes me to flip to the other side of the fraction bar and it becomes positive. Now I'm going to plug these things in. And just like always, I use parentheses when I plug in. So that's negative 3 in parentheses squared over 2 in parentheses to the third power. And now it's just a matter of simplifying. Ready? Negative 3 in parentheses to the second power is a positive 9. 2 to the third power is a positive 8. So I did the exponents. Now I'm going to do that multiplication up top. That's a 27. And then divided by 8, I can go ahead and leave it like this as an improper fraction. If you want to write it as a decimal, I guess that's okay. If you want to write it as a mixed number, that's okay. But why do the work? Let's leave it as an improper fraction for now, okay? In any other context, like in science or something like that, the decimal is going to be the best answer, okay? If I look at something like this guy, again, let's take care of those negative exponents first. So the 2, once again, that 2 has its own exponent. If I don't see an exponent, it's an exponent of 1. Okay, so that's 2 to the first. Now let's start moving things around. The 2 stays where it is. The a to the negative fourth, I send that to the other side of the fraction bar and make it positive. The b to the negative first, I send it to the other side of the fraction bar and I make it positive. The c to the negative second, I send it to the other side of the fraction bar and I make it positive, okay? This is what negative exponents do. Now let's substitute in. Ready? In parentheses, negative 1 squared. Parentheses, 2 to the fourth. Parentheses, negative 3 to the first. And now let's simplify. Negative 1 to the second power is a 1. A positive 1. 2 to the fourth power is a 16. Negative 3 to the first power is a negative 3. Continue to simplify. That's 2 over a negative 48. And then I can reduce that. That's a negative 1/24. Done and done. Okay? If I take a look at this last one here, a couple pieces to a word problem. It says the population of bacteria doubles every hour, modeling this equation, all right, where h is the number of hours after scientists measured the population. And so if we're talking about, this is called an exponential function. This is why we learn rules of exponents, so we can manipulate these kind of equations. And these kind of equations are very realistic in terms of real world examples, okay? So what was the scientist's initial measurement? Well, when the initial measurement, that would be the time of 0. This is a big thing in science when you talk about initial measurements, all right? The initial measurement is where the thing started. You always start with a time of 0. You know, when you go to time something using like a stopwatch, the stopwatch starts at 0 seconds, okay, until you hit start. So the initial time is 0. In other words, it's saying, hey, plug a 0 in here for h. And if I plugged a 0 in here, 2 to the 0 power, and again, you got to follow order of operations. I do the exponent first. 2 to the 0 power is a 1. Now I multiply, and I get a 1,000. So the initial population is 1,000 bacteria cells, okay? Same thing with the next one. It says, what was the population 3 hours prior? All right. And again, when you're talking about science, positives and negatives talk about direction most of the time. Okay. So if I said 3 hours after the initial measurement, we plug a 3 in. That's obvious. But 3 hours prior is like negative 3 being plugged in. Okay, this is how we use negative exponents and negative values in science, is we use it to indicate direction. So if I want 3 hours before the measurement, I use a -3. Okay, and so here we go. That's 1,000. 2 to the negative third power. That means I want to divide by 2 to the third power. That's what a negative exponent means. And now 2 to the third power is an 8. And now 1,000 divided by 8, I believe, is 125. And you see what's neat about that? Even though when the scientists showed up, they measured the population at 1,000, they can work their way backwards to see what the population was 3 hours before they got there after figuring out how this population is growing. Okay? So again, 0 and negative exponents. Anything to the 0 power is 1. Negative exponents, there's just a fancy way of writing division. So we flip the thing to the other side of the fraction bar and make that exponent positive.